Right, so they're asking us to find, they want us to graph it. The direction said graph this function and use the graph to find the limit. So this, of course, is just a a linear equation, and it goes through 1 on the y-intercept, or the y-axis, and then it goes up 3, 1, 2, 3, over 1, 1, so your graph's going to be like that. And so they're asking us to find the limit as x goes to 4. So again, what limit means is simply 2, 3, 4. What value, if I go up to the graph, which is going to be up here somewhere, what value would you expect that, what value would you expect to get for the y, meaning, let's follow this over here to the y. What would you expect the y value would be as x gets closer? Imagine being on this line. You're getting closer and closer to the x value of 4. Well, what's the y value going to be? Well, all you got to do is plug in 4, because that's what the limit's going to be. The limit's going to be whatever the function value is.
Okay.
Because there's nothing funky going on with this one, so the answer is just 13. The limit as x goes to 4 of f of x is 13. Now, if you had something like, if you had some crazy graph, like, for instance, a graph that was linear up to here, and then it jumped up here, and it was linear again, let's say, like a piecewise graph. And let's say this value right here was 2, that x value is 2. And now the limit doesn't exist, because as you get closer and closer on this graph coming from the left, as you get closer and closer and closer to that x value, you'd expect the x value at 2 to be whatever this is. Let's say it's 2. You'd expect it to be 2, but if you're coming from the right and getting closer and closer and closer, you would expect the value to be whatever that is. Let's say 4. And so the limit does not exist. The limit as x goes to 2 of this function f of x, assuming the green function is f of x, does not exist, because it's different coming from different directions. What's the limit as x goes to 0 of f of x for this function? We'll find out what the 0, here's 0 right here, whatever that point is. Let's say it's 0.9, and that's the limit. So that's the basic concept behind what a limit is. Okay, here's a little bit more complicated problem. Now, notice for this one, if we plugged in, remember what I told you, if you can plug if you can plug that value into the equation and find an answer, as long as it's a continuous function, that answer is going to be your limit. But if you plugged 1 into this, for all the x's, you're going to get 0 on the denominator. And you're also going to get 0 in the numerator, which means it's a whole. You remember rational functions? That means that this is a whole. So let's factor this, and I bet you there's going to be an x minus 1 in the bottom and an x minus 1 on the top as well that are going to factor out. Let's do that real quick. So this bottom one, if I take, this is going to be by grouping. If I take an x cubed out of here, it's going to be x minus 1. And if I take a negative 2 out of here, it's going to be x minus 1. Did I do that right? Positive 2. If I take a positive 2 out of there, it'll be x minus 1. So here's your answer. X cubed plus 2 times x minus 1. See, I'm factoring that.
Yeah.
Same thing with the top. If I factor an x squared, if I take an x squared out of this, I'll be left with an x minus 1. And then I just have plus 1 x minus 1. So when I take this out, it's going to be x squared minus 1. So what I can do now is I can cancel these two. And so my revised function is going to be x squared minus 1 all over x cubed plus 2. Now, what's the limit as x goes to 1 of that? Can I plug 1 into this problem? I can. I'm going to get 0 over 3, which is just 0. You know what that means? That means that this graph and this graph are the exact same thing with one exception. This graph right here, when I get to 1, the answer is going to be 0. This graph right here, if I were to look at it on the graphing calculator, when I get to 1, it's going to say undefined, because there would have been a hole right there. because you're not allowed to plug one into the denominator there.
Okay.
So the difference between these two graphs is the whole, and that whole is the limit. So rational functions, we dealt with these a lot, and we didn't talk about limits, but that's what was going to naturally happen, is we were going to get eventually back to rational equations, rational functions, and look at where there are removable discontinuity, and that's going to help us understand the idea of limits again. So your graph would probably be something like, let's see, kind of guessing, but it'll be something like that. There's probably going to be a slant asymptote or something, and who knows, whatever. But there's going to be a hole here is the main thing.
Okay.